Hyderabad, endearingly called the Pearl City, is one of India's fastest growing cities. It offers a fascinating panorama of the past. With a richly mixed cultural and historical tradition spanning over 400 colourful years, Hyderabad has something to offer for each one of us. Heritage monuments, lakes, temples, museums, delectable cuisine and a delightful shopping experience. Hyderabad has it all. Today, it has emerged as a strong industrial commercial technology centre and is seeking to be a globally preferred destination. As human needs and activities overload our planet, many countries have introduced statutory waste minimization and recovery targets to address the Earth's dwindling resources and the growing mountains of waste. The population growth, rapid urbanization, and the changes in the city of Hyderabad has seen coming of the Greater Hyderabad Municipal Corporation. The Greater Hyderabad Municipal Corporation, or GHMC, is the local government for the cities of Hyderabad and Secunderabad. Improper management of municipal waste by disposing it unscientifically into open dumps and landfills is creating huge problems to public health and environment. With a commitment to better the environment and to provide the best sanitation services to the citizens of Hyderabad, Ramki Enviro Engineers, a pioneer in waste management, has established a quality delivery system, the Integrated Municipal Solid Waste Management Project. The HIMSW project uses the most environmentally sound strategies for municipal solid waste. Scope: door-to-door collection, secondary transportation up to transfer station, transportation from transfer station to processing and disposal facilities, processing and disposal, transfer stations, reclamation and alternative use of existing 4 dump sites. Components: compost plant, refuse-derived fuel, waste to energy, landfill operations, capping of existing dump, leachate management. The waste transported from the transfer stations is brought to the facility where each truckload is weighed and data entry is made using computers with data servers for storing, retracting each entry. The weight trucks offloaded at the tipping floor of pre-sorting unit are loaded onto conveyors using dozers. The waste is passed through a 100 mm rotating screen or trommel with screens of 100 mm sieves. The recyclable material, like plastic bottles, is recycled at a recycling plant inside the facility. The material besides the recyclables, with size more than 100 mm, is known as combustible material due to high calorific value. Refuse-derived fuel. The segregated combustible material is further processed to get refuse-derived fuel or solid recovered fuel. The combustible material is stored on a dry concrete platform to ensure maximum moisture removal by sun drying. The dried material is fed to the hopper of a primary shredder, where the material greater than 100 mm is shredded to 80 to 100 mm material. The primary shredded material is fed to the hopper of a secondary shredder that reduces the material size to less than 25 mm. The secondary shredded material is then conveyed to a baling machine for packing the material. These bales are then stretch wrapped and transported to cement industries as fuel. The segregated material passing through the 100 mm sieves of trommel are further processed using windrows process. The windrows are turned for 28 days to ensure complete exposure of organic material to oxygen. The windrows are sprayed with herbal sanitizers to ensure better decomposition and ensure no odor is generated. The material from the windrows section is further refined by passing it through rotating screens of 35 mm sieves. The material with size more than 35 mm is segregated, which can be briquetted and used as an alternative fuel to fossil fuel in energy-intensive industries. Material less than 35 mm is further screened using trommels with screen or sieve size of 16 mm. The material with more than 16 mm size is segregated and briquetted for cement industries as fuel. The material less than 16 mm is stored in the curing section for final screening and curing. In the curing section, the output of 16 mm screening is sent through final set of screens or trommels, which segregates materials less than 4 mm. The final output is refined, which meets the fertilizer control order standards and is used as biofertilizers in agricultural sector. The final output is further blended with additives to improve the product value and packed in a blending and packing shed for dispatch to fertilizer companies. Other recovered products include coconut coir pits from shredding of coconuts. The coir is baled and sent to small-scale industries and as fuel to factories. Waste to energy. The waste from the trucks is tipped in a storage pit. The storage time for the waste is 7 days with leachate addition for charging the waste. The charged waste is fed to a hopper using cranes. The waste is then passed on to moving grates that combust the waste at a temperature of 1100 to 1200 degrees centigrade. The engineering design of the furnace ensures that the intermediate gases go through complete combustion to maintain a temperature of 850 degrees centigrade. Maintaining this temperature ensures that dioxins and furans are not formed in the process. The heat energy is passed into a boiler for generating superheated steam. This steam is used for driving the turbine and electricity generation. The electricity generated is exported to the grid after captive consumption of 15 to 17% of total electricity generation. The residual gases from the process are passed through air pollution control system, which comprises of scrubbers for removal of acidic gases such as nitrogen oxides, sulfur dioxide, hydrochloric gases, any heavy metals, and activated carbon filters. Any particulate matter is removed by using dust collector systems and precipitators. The bottom ash from the incineration process is removed and can be used for construction purpose. Landfill. The processing of waste generates various byproducts. The inert material that is essentially present in the waste or is a rejected material of the process is disposed to a secure landfill. The landfill comprises of multiple layers of boulders, clay, HDPE sheets, geotextile, and leachate collection network of HDPE material. These layers are of varying thickness to ensure that no leachate from the landfill percolates the soil and groundwater. Landfill operations are closely monitored to record any leachate movement. Capping. The existing site for waste management facility has the legacy of years of waste dumping. The waste dump is capped using scientific methods. The process requires laying of HDPE piping network for collection of leachate, covering of soil followed by clay lining, geocomposites, additional thicker soil layer, and vegetation cover. Piping network is also laid for collection of any methane gas and flaring to mitigate release of greenhouse gas emissions. Leachate management. Leachate management is a crucial aspect of the HIMSW project. All the waste stored and waste management processes generate leachate. The leachate generated at site is collected through an extensive pipeline network. Raw leachate is pumped to a chemical dosing tank with flash mixer. Alum or coagulant is added to the tank to create flocks from the suspended solids in the leachate. The leachate is passed into lamella settler that settles the flocks of suspended particles. The supernatant is passed through pressure sine filters that remove the remaining suspended solids and reduce turbidity. The leachate is then passed through a two-stage reverse osmosis system, which uses membranes for filtering the leachate of all contaminants and provide clear permeate, which is used for greenbelt and landscaping development. As we do our bit for the environment and for the generations to come, we strive to deliver service excellence to save natural resources, conserve energy, reduce pollution, reduce the toxicity of our waste, and save money for consumers and businesses. The project is a model for inclusive and sustainable development for our society. HIMSW extends the vision of Ramki Group towards sustainable development.
Giáo dục môi trường trên từng một bậc thang rất là hay. No shape, no pain, every drop and water. You must to pay depth and nature. Shape is on top right quality. Everything here is come in this step. Okay, nice. Key to shape is in your hand, land in hand is shaping diamond. And với 6 tầng liền, tầng nào cũng có những dòng chữ và những cái thông điệp về bảo vệ môi trường. Thật là háo hức khi mà tôi được đến với một cái trung tâm xử lý dữ liệu, là toàn bộ xử lý dữ liệu về xử lý chất thải rắn của thành phố Hyderabad. Có thể theo dõi toàn bộ nhiệt độ và tình trạng xử lý của các lò xử lý chất thải rắn. Nice. What do you think? What you can speak more details the screen share for everybody? Yeah. Nice. Và bây giờ chúng tôi bắt đầu có thể thảo luận về các cái kỹ thuật về xử lý chất thải rắn ở trong nhà máy này. Có cơ hội đến thăm một nhà máy xử lý rác hữu cơ. Và nhà máy xử lý rác hữu cơ này toàn bộ phân hữu cơ được ủ ra và tất cả được đóng lên tạo thành chuyển lên thành những núi phân compost. Và trước khi cái núi phân compost này là có cả một cái khu ủ rác trước, rất tuyệt vời. Rất nhiều chó ở đây nữa chứ. Kia là những cái khu ủ. Okay. Mọi người sẽ trộn rác theo hàng ngày. Cả từ phía bên trong kia là cái khu ủ rác, khu ủ rác thô khi mà chưa phân loại. Sau một thời gian ủ men thì đây là một cái khu xử lý rác sau khi đã được phân loại cơ bản. Nhưng mà rất là tiếc không được vào bên trong, tối lắm. Đi tham quan những cái khu đơn vị xử lý rác tại đây. Toàn bộ các chất thải rắn được đưa lên đây. Wow.